section 2.4, rates of change, page 8. To see if a tangent line can be drawn to a function f at a point x equals a, there's two things that we need to do. The first thing is we need to check for continuity at that point. And remember, for something to be continuous, the function evaluated at that point must be exactly the same as the limit as x approaches that point. The second thing that we need to check for is slopes of tangents from the left and the right side of A. Check slopes of tangents from the left and right sides of A. Those should be the same in order for there to be a tangent line there. Let's take a look at this example. For this function, f of x is x squared when x is less than or equal to 3, 6x minus 9 when x is greater than 3. We want to know, can a tangent line be drawn at x equals 3? The first thing that we're going to do is to check for continuity. Which means we're going to check f of 3 to see if that is equal to the limit as x approaches 3. And since this is a piecewise defined function, all three of these pieces have to be equal, meaning f of 3 has to equal the limit as x approaches 3 from the left side, has to equal the limit as x approaches 3 from the right side. Alright, this function evaluated at 3, looking back up here, this is the piece that's defined when x is 3, so we plug that in. 3 squared is 9. The limit as x approaches 3 from the left is the limit. The piece that's on the left side of 3 is that x squared. Sub in, and we get 9. This piece over here, the limit as x approaches 3 from the right. The piece that's on the right side of the 3 is the 6x minus 9. Sub in 3 here, and we'll have 6 times 3, 18 minus 9, which is 9. All three of these are equal. That means that the function is continuous. Alright, second part here. Let's check for slopes of tangent lines. We are going to have to check from the left and from the right. Slopes of tangents from the left, that's a limit as h approaches 0 from the left. F of, and we're coming from the left side of 3, so 3 plus h minus f of 3, all over an h. The function that's on the left side of the 3 was that x squared. So this is the limit as h approaches 0 from the left of 3 plus h squared minus, and f of 3 was 9, all over h. Squaring that out, that's 9 plus 6h plus h squared, then minus the 9 all over h. The 9s subtract out. We have the limit as h approaches 0 of 6h plus an h squared over h. And if we divide out that h, we have the limit as h approaches 0 of 6 plus h, which is 6. So slopes of tangents from the left side of 3 is 6. Let's look at slopes of the tangent line from the right side of 3. This is the limit as h approaches 0 from the right of same f of 3 plus h minus f of 3 all over h. The function this time, we're on the right side of 3, so that's 6x minus 9. So in this case, it will be 6 times the 3 plus h minus 9 minus f of 3 minus 9 all over an h. Simplifying, distribute that 6 through 18 plus 6h minus an 18 all over h. 18 subtract out, and we'll have a 6h over an h, which is the limit as h approaches 0 of a 6, which is 6. Oh, look, I forgot my from the right, so I'll replace 0 from the right, 0 from the right, 0 from the right, and I think I did, oh, on the other side too. Go back, 0 from the left, 0 from the left. Didn't affect the problem, it just affected the notation. Alright, so now, go back. What was our question here? Can a tangent line be drawn at x equals 3? Is the function continuous? Yes. Does the slope of the tangent from the left equal the slope of the tangent from the right? Yes. Then a tangent line can be drawn at x equals 3. Yes. A tangent can be drawn at x equals 3. Perfect.